All right, Year 9. I'm just going to go through the proofs that I left you to do, which have to do with the proofs of some geometrical properties that we'd already taken for granted when we did triangles and quadrilaterals. Now, there are three that I want you to do in class. Can I suggest, if you're watching this, that if you're having trouble, watch one and then go away and have a go at another one, at the second one. So the first thing we're going to try to do, and I'm in the proof section of the geometry, is I want to prove that the base angles of an isosceles triangle are equal. So this is the first one. Prove that the base angles of an isosceles triangle are equal. Now, even though we listed it as a property earlier when we did our classification of triangles, we need to be able to prove every property. And we need to do it from the basic understanding of what our definition is. Now, definition of an isosceles triangle is that it's a triangle where two sides are equal. Now, we want to prove that this angle and this angle are equal. And how are we going to do that? So first of all, let's start by labeling our triangle. I'm just going to call it triangle A, B, C. And let's state the aim of our proof. Prove BAC equals BCA. That's our say. Once we've got a diagram, we're away. And here we go. The first thing I'm going to do is I'm going to draw an altitude. Now, an altitude is a line that goes from an apex or a vertex or a vertice and hits the opposite line at 90 degrees. So I'm going to say I've done that. And I'm going to have to put a new letter in here. I'm going to go D. So construct. I have to say that I'm doing this. Altitude from B to AC, meeting in D. Now, what else do I know? Well, I've got everything I need now because I've got a common side. If I'm looking at triangle ABD and I'm looking at triangle BDC, I've got a common side, I've got 90 degrees, and I've got a hypotenuse. So I can use RHS. So this proof's pretty easy. So let's go with the right angle because I'm doing RHS. BDA equals 90 degrees equals BDC. Because we constructed it. It's an altitude. Right angle, hypotenuse. AB equals BC equal sides of isosceles triangle. Oh, I don't need to write the word triangle. Let's try and keep it simple. Triangle ABC, and BD is common. Therefore, triangle ABD is congruent to triangle BDC. Thus, what were we trying to prove? BAC equals BDC. Why? Because they're corresponding angles in congruent triangles. Oh, I don't need that. Okay. Now, there's the proof, and that's why we know that the base angles of an isosceles triangle are equal, because you prove it using congruent triangles. It's not something that's just someone's gone, oh, wow, that looks like that works. They've actually gone through and proved it, just as you will have done after you've copied that down. Now, the next one you need to prove is that the opposite sides of a parallelogram are equal. I'm going to draw it up. You go and have a think about it, all right? And I'm going to do it. If you've gone away and come back, well, here we go. So what we need to do is prove that the opposite sides of a parallelogram are equal. Well, first I'm going to draw a parallelogram. I hope you're using a ruler. It's very hard for me here because I'm using a Surface Pro and I can't, well, there are ways to do a ruler, but it just takes too long. And I want to do this quickly enough so that you can see it. A, B, C, D. So I'm going to label my points like that. And what do we know about a parallelogram? Well, we know that opposite sides are parallel. That's the definition. Okay. Well, how are we going to do this? We've got to prove that BC equals AD. All right, so we're going to prove BC equals AD. We're going to prove that AB equals CD. Again, what you need to do is construct, and I'm going to construct the diagonal there. All right? So, construct diagonal AC. Now, what am I going to do? If I look at the triangle ABC and the triangle ADC, if I can prove they're congruent, well, I can show that both sides or the corresponding sides are equal. Well, what do I know? I know that that's common. I know that this angle and this angle are equal because alternate angles. And I know that this angle and this angle are equal because they're alternate. So I've got angle, corresponding side. And then we can prove it. So let's write it up. We know that BCA equals CAD, alternate angles and what sides? BC, A and CAD. That's because BC is parallel to AD. And we also know that BAC equals ACD. And you love this one. We can write similarly. And this time, AB, that's awful, is parallel to CD. And finally, AC is common. Oh, by the way, I didn't write Y here. I should have written RHS. That was bad. So, therefore, triangle ABC is congruent to triangle ACD and Y angle side. Let's just check. Yeah, there we go. ABC, ACD. Thus, AB equals CD and AC equals, BC, AD, Y, corresponding sides in congruent triangles. Okay, there we go. The final one. You go and have a go at it yourself, but we need to try and prove the diagonals of a rhombus bisect each other at 90 degrees. We'll draw our rhombus. Now, we've just proved that the sides are equal, so we're not going to prove that again. I'm going to label this A, B, C, and D. And we know they're parallel. Part of our definition says that adjacent sides are equal, and because we just proved that opposite sides are equal, they're all equal. Now, I'm going to have to prove that the diagonals bisect each other at 90 degrees. So I'm going to have to go down here. I'm going to have to go up here. So what I'm going to do is I'm just going to look at triangle, and I'm going to call this middle point E. So in the rhombus, I should have done this earlier this way, A, B, C, D, construct diagonals AC and BD, that's a bad D. Meeting at E. Well, what do I know? I want to look at this triangle, and I want to look at this triangle. Now I've got a side, and I've also got, well, this angle and this angle, see the Z, and this angle and this angle. Now if I can prove they're congruent, you watch what happens. So let's start with the top triangle, B, C, E. Well, let's call it BCA. Doesn't matter if we go down all the way down there. BCA equals CAD alternate angles BC parallel to AD, and CBD equals ADB similarly. BC equals AD sides of a rhombus We really should prove that, but we did it just before in the previous proof, because the definition of a rhombus is that its adjacent sides are equal. Once you get that, all sides are equal. Therefore, triangle BCE is congruent to AED, triangle AED. What reason? Angle, side. Therefore, or thus. Now, this angle and this angle are equal. All right? Now, I know that doesn't prove that they're 90, but it does prove that they're equal. Thus, BEC, BEC equals AED. So we're almost there. But what we're going to now do is we're going to look at this triangle and this triangle. All right? Actually, that would have been a better way to go from the beginning. That would have given it to us straight away. That would have got us meeting them at 90 degrees. So probably wasted a bit of time there, but it doesn't matter. So let's take, what do we got? BC equals CD, sides of a rhombus, CE is common, and BD is the base of that isosceles triangle. So CBE equals CDE, base angles of isosceles triangle BCD. Therefore, triangle BCE is congruent to CED. Why? Well, what have we got? Two sides and, oh, it's not the included angle. It's not the included angle. Two sides, we haven't got the included angle. That's not going to be enough. We're going to need to go another, we need the included angle. It must be the included angle. So I need to get this, this angle in here. So, and I've almost got it. So I've got this angle. They're equal, but that was a bit of a waste of time. But because I've proved over here that these two triangles are equal, I know that CAD is equal to BCA, and I'll know so that CA, okay, so here we go. So let's go with this. CAD equals ACD, Y, base angles of isosceles triangle CAD, because CD and CA are equal because they're sides of a rhombus. So I'll put that up here. CA equals CD, sides of a rhombus. So that little x in there equals that little x in there. And we proved over here that BCA is equal to CAD. So we already knew that BCA equals CAD, but we can restate it. Alternate angles. Therefore, what are we trying to show? That BCA equals CD ACD. Therefore, BCA equals CAD equals ACD. Thus, triangle BCE is congruent to CAD right? Y. Now we've got side angle side. Because remember, we've got, I'm going to use a different highlighter. This is going to look ugly now. We've got this side, and this side, and the angle in between. Righto. Now that we've proven that, we're going to know that this angle and this angle are equal, and because they're on a straight line, they'll be 90 degrees. Hence, BEC equals CED corresponding sides in congruent triangles and BED is a straight line, therefore BEC equals 90 degrees equals CED. So we've just proved that that angle is 90 and that angle is 90. Now, to prove that the diagonals bisect each other, you can just go and then state the corresponding sides of all those triangles must be equal. So if I look at that line and that line, they're going to be corresponding sides in this triangle and this triangle. And I'm running out of colours here. This line and this line are going to be corresponding sides in these two triangles. And because of that, the diagonals are bisected. All right, now that is a really long and difficult proof. I put it in there so that people would see it. The first two were reasonably easy. All right, proving the base angles, proving the opposite sides in a parallelogram. But there, you had to do two congruency proofs to get there. All right, I hope that helped you out for those people who were able to do that. Hope you had a good lesson trying to do those proofs.